8,000 meters above sea level, an altitude so high there is not sufficient oxygen for humans to breathe nor live. Australian mountaineer Lincoln Hall was no stranger to the danger of oxygen deprivation as he experienced it firsthand during his second ascent to Mount Everest on May 2006. Hall was reportedly experiencing hypoxia, suffered cerebral edema, and exhibited hallucinations before his collapse. So what is hypoxia? It happens when your blood doesn't carry enough oxygen to your tissues to meet your body's needs. We may apply scientific concepts from other fields. For this, we have Dalton's law of partial pressure. Partial pressure is defined as the force exerted on the container by an individual gas in a mixture. Going back to his law, it states that the total pressure of a mixture of gases is equal to the sum of partial pressures of the component gases, wherein total pressure is equal to the pressure of gas 1 plus pressure of gas 2 and so forth. Atmospheric pressure is inversely proportional to altitude. That is, as the altitude increases, atmospheric pressure decreases. This is because the air molecules are constantly being pulled downwards. Changes in altitude affect atmospheric pressure, and therefore, oxygen levels, creating the condition known as thin air. If a person climbing to a high elevation does not take the time to acclimatize slowly to the decrease in air pressure and oxygen, altitude sickness will result. Mountain climbers use bottled oxygen when they ascend very high peaks, taking time to get used to the altitude, because quickly moving from higher pressure to lower pressure can cause the bends. Another problem is that low air pressure can cause fluid to leak from the capillaries in both the lungs and the brain. Oxygen is transported in the body with the help of the circulatory system. The uptaking of oxygen is done in the lungs. Blood flows via capillaries in the walls of the alveoli. Once inside our body, oxygen changes from gas molecule to dissolve, one which then pick up the red blood cells. The red blood cells contain hemoglobin, which are proteins attached to red blood cells that bind the oxygen. At sea level, atmospheric pressure is about 1014 millibars. 78% of this is composed of nitrogen at 790.92 millibars, while oxygen accounts for 21% and is at 212.94 millibars. Traces of other gases are at 10.14 millibars. At 30,000 feet, roughly about the height of Mount Everest, atmospheric pressure drops drastically to 265 millibars. For the body to function properly, we need about 207 millibars, but notice that oxygen's partial pressure decreases to 55.65 millibars, making it difficult for oxygen to make it through the lungs. This lack of oxygen can cause consciousness, dizziness, disorientations, hallucinations, and worst-case scenario, death. How it is treated. You'll need to go to the hospital to get treatment for hypoxia and to keep a check on your oxygen level. The most important thing is to get more oxygen into your body. You'll receive it through a small plug in your nose or through a mask that covers your nose and mouth. For many people, this is enough to bring your oxygen level up to normal.